Welcome to all. I am Sajida I, Assistant Professor, Computer Science and Engineering, Jyoti Engineering College. In this session, I am going to discuss about the storage classes concept in C programming language. So, what is a storage class? Generally, in the declaration of every variable, we need to specify its data types. We know why we need to specify the data types. This data type is representing what is the size of variable and how much memory is allocated and what type of data allowed to store. But along with that, we need to specify its a storage class also. So before going to the actual concept of storage classes, we need to know what is the use of storage classes. So for every variable that we are declaring in C program have some specific scope and lifetime. So first of all, what is scope and lifetime? So scope or visibility means it's a region where the variable can be used, and the lifetime, how long a variable holds the memory. So a storage class defines the scope and lifetime of variables within a C program. So what is actually the storage class? A storage class defines the scope and lifetime of variables within a C program. So scope means a region where the variable can be used. Lifetime means how long a variable holds the memory. So a storage class defines the scope and lifetime of variables within a C program. So we have four different types of storage classes. There are four different classes in C language: automatic, external, static, and register. So these are represented by the keywords. For automatic storage class, we are using the keyword auto. And for external storage class, we are using the keyword extern. And static storage class, static. And for register, register itself. So these are the keywords that we have to use uh, for the declaration of different types of storage classes. So this is the syntax of declaring a variable by using its storage class. Storage class space data type space variable name. For example, if it is an automatic variable, then auto int I. And if it is static, static int I, extern int I, register int I. Like that, we can declare every variable by specifying its storage class. So first of all, what is an automatic storage class? The auto storage class is the default storage class for all local variables. Scope can be, we need to consider three measures, that is scope, lifetime, and default value. So what is the scope of the automatic storage class? Scope can be used in the same block in which the variable has been declared. And the lifetime of automatic storage class is the variable is alive only in the block in which it is declared. And the default value of automatic variable, sorry, local variable is garbage value. Automatic storage class variables are local variables. The default value of the local variable is garbage value. So these are the three things that we need to remember regarding the automatic storage class: scope in the same block itself, and lifetime, the variable alive only in the block in which it is declared, and the default value will be the garbage value. So for example, if we are declaring a variable like this in space x, it is same as the declaration auto int x. Both the declarations are same. If you are declaring a variable as simply int x, and if you are declaring the variable as auto int x, both are same. So x is an automatic variable, automatic storage class. Here we can see an example for automatic variable. So this is a program hash include stdio.h is the main program. Here we have two functions, main function and the increment function. And inside the main function, we can see three function calls, and this is the function body. And the function first function call, the control will goes to the function body. Then here we can see auto int a is equal to 0. So I have initialized here a as 0, and a is equal to a plus 1, printf a is equal to percentage t comma a. So during the execution, whenever it executes the first function call, then the control will goes to the function definition. Then a is equal to 0, then a becomes 1, then so a is equal to 1. The output will be a is equal to 1. Then when control will goes to the function main function, then we are declaring the variable a inside this function increment. So this A is local to this increment function only. We will not get A inside this main function. That is the feature of this automatic variable. Means the lifetime and scope of the automatic variable will be inside this increment function only. And whenever the control goes to the main function, its lifetime will be end and its scope will be ends. So during the second call, what happens is that again the increment function body will activate and A will be initialized as 0, A will be incremented by 1. So we will get the answer as A is equal to 1 again. Then again the control switch to main function, third function called increment, then again control switch to increment function body, then A will be initialized as 0, A is equal to A plus 1, then A is equal to 1. So for three function calls we are getting the same answer, A is equal to 1. So what we can understand from this example is that automatic variables are local variables, and the lifetime and scope of this local variable or automatic variable inside this function body, this increment function body, that is in this particular block only it exists. That is the meaning of this example. So that is about automatic variable. Then next is static storage class. So in the case of static storage class, the scope of static variable in the same block in which the variable has been declared, that is same as automatic storage class. The scope of the static storage class is same as automatic storage class variable. Same block in which the variable has been declared, and the lifetime. The lifetime of a static storage class variable will alive until the program. The variable will alive until the program terminates. So during through the entire program, the static variable will exist. So that is the difference between automatic variable and static variable. Then the default value here is 0. So whenever we declare a variable as static, then we can give like this static space in space x. So here we can see an example for static variable. The previous example, instead of automatic variable, here we are using the static variable. In the previous example, the variable A was auto. Here it is static. So what is the difference? So here main is a block, increment is another block, and during the execution, first call increment function will execute, increment call will execute, then the control switches to here, then A will be declared as a static int variable and it is initialized as 0. So in the case of static variable, no need of this initialization because default value of static variable is 0. A is equal to A plus 1, then A will be incremented by 1, print A is equal to 1. So that is the first answer, A is equal to 1. And during the second call, what happens is that here the initialization of variable will not work during the second time because the static variables will be initialized only one time in a program. Then here A is equal to A plus 1 means previously the value of A was 1. So now A is equal to A plus 1 means A becomes 2. So printf A is equal to 2. Then during this third call, what happens is that A is equal to 2 plus 1. Then printf A is equal to 3. So in the case of static variable, what we have seen that uh, only the initialization happens one time and throughout the entire program. After that, the previous value will be maintained till the end of the program. That is static variable. Then next is external variable. So what is external variable? External variable is same as global variable. Global variable. It says the compiler somewhere the declaration has been done. The compiler will check for the initialization of a particular variable. So syntax of the external variable is we can give the keyword extern int I. So I is an external variable or global variable. That means we can access the global variable in any function in a program. Whereas in the case of static variable, we cannot access the static variable throughout the entire program. We can access the static variable inside a particular block only. So it is local to that particular block. Whereas in the case of external variable, it is global variable. We can access the global variable inside any function. Then, what is the scope of this external variable? Throughout the program, we can access the external variable and lifetime variable alive until program completes its execution. It is similar to static. The variable alive until the program completes its execution. Then the default value of the external variable is 0. So whenever we are giving this type of declaration, then extern int I, 2 bytes or 4 bytes will be allocated in memory for I and initialized as 0. That is the features of external variable. Scope of the external variable throughout the program. So this is an example for external variable. Here, here there is a main function int x is equal to 3. Here x is an automatic variable. Extern into y. Y is an external variable. Then printf x is equal to x means here x is equal to 3. So x is equal to 3. Then printf y is equal to y. Here y is initialized by default. The external variable initialized as 0. So the answer will be y is equal to 0. Since there is no initialization for y, it will print default value. The default value for external variable is 0. So this is an example for external variable, and here a little bit change in the previous example. Here what the change is int x equal to 3 extend into y print of x equal to x print of y is equal to y. And after the main function you can see y is equal to 10. So then the output becomes x is equal to 3 and y is equal to 10. Why? Because during the compilation time itself, the compiler will fix the value of y wherever it is initialized. Y, here y is equal to 10. After the main function, the compiler will not y is equal to 10. So the value of y will be replaced as 10. So we will get the output print of y is equal to 10. Since y is initialized as 10, it will print y is equal to 10. So that is the feature of or advantage of external variable. Then the last one is the register storage class. So register storage class means if any variable declared as register storage class, then the compiler will allocate one register of a processor to store the value of a variable. Registers are the temporary storage unit in CPU. Instead of storing value in RAM, it will store in registers. If register is not available, then it will store in memory. So whenever the compiler sees a register variable, then automatically it will allocate a particular register inside the CPU for that variable. Mainly we are using these register storage class variables for the frequent access. For example, in the case of looping statements. The use of register variables recommended only for those variables which are used frequently in a program. So in programming, which type of variables we are using frequently? We are using frequently the loop counters, isn't it? Loop counters are used frequently. A typical application is in loop counters, which may be used a number of times during the program execution. So what about the scope of the register variable? It will be in the block in which the variable has been declared. The lifetime, the variable alive only within the block. So only within the block, the scope and lifetime of the register value variable holds. The default value, garbage value. Here you can see an example for register variable. Here is the main function, register int I. For I is equal to 1, I less than or equal to 5, I plus plus, print percentage d I. So first of all, I becomes 1. Next, I increments by 1, then 2 less than or equal to 5, yes. So print f2, then 3, 3 less than or equal to 5, print 3, then 4, 4 less than or equal to 5, print 4, then 5 less than or equal to 5, 5, then print 5. So the output becomes 1, 2, 3, 4, 5. So 5 times here we are accessing this I. Frequently we are accessing the variable I 5 times in 5 times. Suppose this was 500, then 500 times we are frequently accessing I. So in such situations, for a faster execution, program, in order to execute the program faster, we need to use the register variable. So these values will be stored in CPU registers rather than in memory. Program execution faster than the normal program. So that is the advantage of using register variables in a program. The program execution will be faster than the normal program. So where we are using this register variable, we are using register variable for frequently accessing variables. So these are about the four different types of storage classes. Thank you.